Hey guys, welcome back to the free Unity course in which we learn about C# and the Unity engine. So this is actually something you learn quite early on when you take other C# course, but like I said, we're taking things in a different manner here. We're learning both C# and the engine at the same time. We're learning how to read, then we learn how to do condition. Today we're going to be looking at the for loop. So I'm going to go over here in my start, so just bear with me. I'm going to go in my start. Just disregard all the code we have. We're going to leave it here because we need it to have our game running, right? But just imagine this is a clean start. Type in for and then double tap on tab, which created the for loop for me. Now let's have a look at this. This is what they wrote for us. A for loop is actually split into 3 different little statements. Let me highlight them for you. So that's the first statement, that's the second one, and that's the third one. So they're all split by a semicolon. The first space here is actually used to declare a field, so you can declare a field. In this case, they've created a new int I, a new integer, they assign it to 0, and then in the middle is a condition. So this for loop is going to be ran over and over and over again until this condition is no longer met. So in this case, we could say something, so we know that I is equal to 0 right now. As long as I is, say, smaller than 5, we keep running this. And then finally, the last part is what is going to happen when you're done with one iteration. Now that sounds a little bit complicated, but just bear with me. Let's have a look at what this gives us inside of the game. I'm going to say debug.log. I'm going to debug the amount that is stored inside of I. So this might be, like I said, this might be a little bit messed up right now in your head, but don't worry too much about it. If you have a look at the console down here, as soon as we press unstart, it says 0, 1, 2, 3, 4. Now let's have a look at the for loop. We declare int only once. At the beginning we say for int I is equal to 0, and then we say as long as I is smaller than 5, then we keep running the code inside of here. Now when we're done, we run the last part of the for loop, which does I++, so you increment your I every single time you're done with that. And to recap really quickly, your code runs here, then it enters the for loop, it declares the int only once, then it checks the condition. Is that condition met? If it is, let's go ahead and run that code over here. Now, you're going to run that code, and as soon as you're done running that code, as soon as you're done with your first iteration, once you reach that point, you're going to go over here and do that operation, so I++. Now at this point, it's going to be like, well, is our condition still true? And if that condition is still true, we go back here and we run our code again. So debug.log I, and then again it checks I++. Is our condition still true? If it is, go over and over and over again until the condition is no longer true. Now you could be easily freezing your game if you did something of the sort. So as long as I is say bigger than 0 or -1, now this would actually crash our game because that for loop would be ran over and over and over again, and there's no stop. You know that, like, there's no way to get out of this for loop because you're always doing I++, and you know there's gonna be no limit to this basically. So you gotta be careful here to actually put something that makes sense and that is eventually going to exit the loop. Now the purpose of this thing that I'm doing here today is to actually iterate through the arrays we have. We have a 10 by 10 array, if we can remember this array here. I want to iterate through it and then give me, you know, just a debug.log of the value inside of that array. Now here is how we are going to go about it. So I'll do that in the start for now, but then we'll have to do it every time we move. We're going to do a for int I is equal to 0 as long as I is smaller than the length of our array here. Now our array is actually a multi-dimensional array, so usually just imagine yourself that you had like a regular array, a one-dimension array. What you would go and do is something like this. So grid.length. You're able to actually get the length of that grid, which if we had a one-dimensional array here, like that, it would return 10. So as long as I is smaller than 10, and you can actually go through every single one of your integer value in your grid just by typing something like this, because I is always incremented by 1 every single time the for loop is over. So you know that the first time this is ran, I is equal to 0, that's cool. Now the second time it is ran, I is equal to 1, and then so on. I is equal to 2, I is equal to 3, and you can actually have an operation on every single value inside of your array. So that is for one-dimensional array. So this is for like regular array. But in our case, we're using a two-dimensional array. So instead of getting, dot length is not going to work here because we have a 10 by 10, which is going to give you, I think it's going to give you 100. I can't be 100% sure on that, but dot length is not going to work here. So I'm going to show you something that we really rarely use. It is a function in your grid. So you have the grid right here. The grid holds function. You can say get length on it, and then it takes the int dimension. You can't see it on my screen because for some reason I can't record the little pop-ups, but it takes in the int, and the int is called dimension. So if I actually type in 0 in here, it's gonna get the length of my first array, which is this one. And just like this, I should be able to iterate through every single one of those. So let's go ahead and write something really custom right here in our debug.log. We're gonna send in a string that we're going to be building up as we go. So let's start with this. We're going to say x 2 dot space plus I. So technically what should happen right here is we have a string and then we have an int. Now Unity is smart enough to know that this int is actually going to be read as a string value. So just imagine that this is two strings added up together. We're going to go down here in our game and have a look at the console. So it says x0, x1, 2, 3, and 4 until 9, which means we went through every single one of those arrays. That's totally perfect. Now, I'd like to actually get the value that is inside of that as well. So to get the value, we're going to do plus, say value, 2 dot. Now I'm just creating strings on the fly. And we're going to go ahead and just fetch that value. So we know that we are I in x, and let's say we're going to be using only the first row for now, so 0 in y. So we're only reading this first tile right here, and technically there should be nothing in that. They should all be on 0, and as you can tell, it is all on 0. So that's pretty useful, but we still have the same problem where we have a two-dimensional array here, and we're only going through a single, we could say a row here, this first row. Now what we need to do is actually read on 2 rows. So what you can do if you want to actually iterate through a two-dimensional array or three-dimensional array or four-dimensional, as much dimension as you want, is to actually do another for loop inside of your for loop. So I'm going to be using j here, and we're going to say grid get length of the actual array at index 1. And if that is met, we're going to say j++. Now let's move over our debug.log and say, so the x value is going to equal to I, and then we're going to add up something here. We're going to say the y value is going to equal g. And then we can actually look for a value. So, and the value is going to be grid at I and j. So if we actually play this now, we should get 100 debug.log. And as you can tell, we do get 100 of those because of the little speech bubble we have right here. It says 100 log. And now if we just look down, here it is. So at the index 04, whenever the game was started, because this is only run when the game starts, at the index 04 we had the value 1, which means we were able to have the value 1 inside of here. That is pretty much just because this is where our snake starts. And we also assign it right about there. So using this nice little double for loop, we're able to actually iterate through everything. Alright, so now for this double for loop, what I'd like to do is actually put it inside of the move function, which it's not really a function, but like just beneath this thing here, this is when we move. So this is being called once every 0.5 second. Now I want to have this every 0.5 second, and the reason I want this is to see if my other array, my other values are actually being set. So let's pause the game after 6 move. Gonna go to the very top here. So this is where we start. We start at 0, 4. Technically, on the second move, we should be at 1, 4. So let's scroll down. So that's the first one. That's the first move. Now the second one, we should be at 1, 4. And here it is. So 1, 4. And if we go back, 0, 4 is still actually set. So we're gonna do something like this. If grid at the index I and j is bigger than 0, then in that case, we're going to go ahead and just reduce that amount by 1 every time we move. So like this, all the tiles behind us are actually being reset on 0. Now, I'm doing only a minus minus, so say whenever snake length is going to be equal to something like 3 or 5, then it's going to take that number, so 3, and then bump it back to 2. Then after that, on the next move, bump it back to 1, and then finally to 0. And the way our conditions are going to be met is if we enter a tile that is not 0 or not minus 1, then we're going to die. So just hold on tight, we're about to put some visual on that. It's going to be way easier than just looking at this big grid of information. But right now we need to actually have the logic down, so we're almost there, guys. So every single frame, or every single move, iterate through our whole array and reduce every tile that isn't minus 1 or 1. Or 0, sorry. Now, if we just go back at the very bottom here, we're going to create a new condition. Let's have a look down here at grid, snake X, and also snake Y. This is where we're headed, so this is where we actually go. Now, if that value is equal to minus 1, that means we eat an apple. Now, if we eat an apple, we have to remove whatever was on that grid space, and also increase the snake score. So snake score plus plus, and then grid at that index, so snake X and also snake Y, should be equal to our snake score because we're actually going there. Now this is useless, and let me just show you why. We do it down here. So we're not going to be needing it up here, since we know that if we're actually hitting an apple, it means that we managed to do our move. We managed to do our move because apple are going to be spawning inside of the grid. So we know that this is not going to be met, and we can make sure that, this is actually being called. So we only have to do snake score plus plus in this case. Now, what else do we need to do? But then there would be one thing we have to do here. We'd have to create a new apple. So create new apple. We're going to do that really soon, but right now let's just leave it as a comment. Okay, so that's if we hit an apple. Okay, so now let's expand our logic a little bit to check if we're actually hitting ourselves. Which means, if we're not hitting apple, we might be hitting ourselves, or we might be hitting the out of bounds. Now the out of bounds is already being taken care of here, but if we hit ourselves, we're going to do that inside of a else if statement. Now we didn't see what the else if statement is, so just imagine you combine both those things. In case the if is actually not true, then it's going to go to the else if, which is basically just another if. I'll just tell you the difference in between the two in a second. Let's just write it down. So if the grid, snake X and snake Y, so where we're going, is not equal to 0, then we lost. So debug.log, we lost. And I'm going to type in a return statement here, which we will cover in a moment. But first, let's have a look at the else if statement. What exactly does that else if does? So let's quickly look at the flow of this. If this condition is true, then the else if statement is never going to be even ran. It's not going to be considered. If we're hitting an apple, we discard this completely. So this doesn't exist. Now if we don't hit apple, then we still have another if statement to check. And if this one isn't true, we discard it and we just move on like usual. However, if it is true, we do enter this if statement. So basically, if we were just to type in else here, you know that this code would be ran 100% sure, because if that one isn't true, then we're running this. But now, if this one is true, we disregard that. If this one is not true, we still do our condition. So this is what a else if statement is, and it's going to be really useful here, because just imagine this for a second. If we only had that, then, if we hit apple, we would lose, because where we're going is not equal to 0, it's equal to -1. So we're checking that first, and then we do that inside of a else if statement. Now let's talk about that return statement really quickly. And return statement is something that is going to be so very useful for you in the future. But right now, all we have to understand is that return statement, when we call it just like that, it actually breaks the flow of our function, and only our function. It doesn't stop the code, it just returns the actual function, so it stops the function. Which means, when you enter this call, you go back until you actually hit the function, and this is not being run anymore. So we can just run this whole flow here until we hit return, and once the return is called, we disregard this whole thing down here just until we actually hit the last bracket of the update. As you can tell, this is the update. So return is simply just going to cut your code, and then we don't run anything from there. Which means that if we do actually collide with ourselves, it's going to say debug.log, we lost, and it's not going to move us. So it's not going to do the rest of this thing, which is going to be quite useful in our case in case we lose. So let's quickly check if we broke anything, and then we can move on to creating visual in the next episode. So move up, move left, they still all exist, that's fine. And now if we go out of bounds, we did break something. I don't think that's because, okay, so basically we're checking if there's an apple outside of the grid. So this is definitely a wrong approach that we have to fix. And that is exactly why we have some bounds check down here. So we have to take this whole code we wrote and actually place it inside this little place here, you know, this else statement, in case we are inside of the cube or inside of the board at least. Then we check, are we eating an apple or are we hitting ourselves? And if we're not doing any of those things, let's go ahead and just move like we would usually do. So just like this, we should have fixed our game. And like I mentioned, we're going to be doing graphics really soon, just simple graphics, just able to visualize this thing at least. And guys, that is where I'm actually going to end today's episode. And I know I'm kind of ending on a bad note since we haven't really tested out with the real values. But we have a big episode coming up tomorrow. We have an episode talking about visualization of that thing. So we are going to be spawning other game object to do the other part of the snake, and also keeping track of them so we can delete them later on. And also we might look into spawning an apple because we have that mechanic now. So thanks so much for watching. I hope you enjoy, I hope you learned something. And if you did, please leave me a like on the video, that would be very cool. And also check out the Patreon page and also the Facebook page if you wish to support me making more courses. And just keep doing something with this channel. Anyway guys, thanks so much for watching again, and I'll see you in the next one.